Alright, so in this video we're going to be doing some practice with scientific notation, and I have a couple of interesting numbers here as well as a mnemonic that I'd like to share with you. And so let's go and get started with that mnemonic, right? So the mnemonic is let's underline L break world, and this is just to fill in the sentence. Let's break world records on Saturday. Alright, so underlining L, B, R, and S. Okay, so that means that if you move the decimal to the left when doing scientific notation, let me go to the right there here. So left is bigger and right is smaller. Okay, so for example, let's say you had the following number, which is let me go move over to the left, or does it let me? But anyways, let's say we had this number right here, 0.0009. All right. So if we were to express this in scientific notation, first thing we would have to do is count the significant figures. And if you haven't already watched the the significant figures video, or you don't know how to do significant figures, then go ahead and do that, because you need that for this video. But anyways, you need to express the correct amount of significant figures here. Excuse me. So right here, there's only one significant figure, right? Just a 9. The digits to the left of it, because they're zeros, are not significant. Okay, so our answer is going to have one significant figure. But since we want to get the decimal to be to the right of the first non-zero digit, this is where we want it to be. We need to move the decimal over to the right, right? So 1, 2, 3, 4 times to the right to get right there. Okay, so since we move the decimal over to the right, according to our mnemonic, right is smaller, so the exponent should be smaller. So right here we had, let me go and change this to 0.0009 times 10 to the 0. Recall that anything to raise to the 0 is equal to 1. So since we're moving it to the 4 places to the right, this exponent should become 4 places smaller. Alright, so what we should get from here is 9 points times 10 to the negative 4. And that's the same number as 0.0009. Alright, so let's go ahead and transfer that over here to an actual example that I have written for you guys. So I'll be doing my work in black. So age of the Earth in years. The age of the Earth is actually 4.543 billion years old, and that's a lot of years, but many more seconds and many more hours and so on. But anyways, let's see, how do we express this number in scientific notation? All right, so let's go and start our work over here. So this is where the decimal place is, right here, right? So what we want to do is get the decimal point to this spot right here. So we're going to be moving to the left. 1, 2, 3, 4. Oh, sorry. Made a mistake there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places over to the left, right? So we should express all of these scientific or significant figures. And we know that in this number, since all these zeros are to the right of the non-zero digit, they are going to be significant. All right. So we know that there's 3, 6, 9, 10 significant figures here. So we should put 4.543 as well as, so that's 1, 2, 3, 4, as well as 6 zeros. So 1, 2, 3, 4, 5, 6. And that is something you're expected to do on the exam and on your homework. Even though those zeros look weird, they are important to your answer because they are significant figures. All right. So right here, since we moved to the left, how many was that? 9 places to the left. We know that our exponent should be getting bigger, right? Because left is bigger, right is smaller. So we had times 10 to the 0, right? Now we should have 9 places bigger than that. So our new exponent should be times 10 to the 9. And that's 4.543 with 6 zeros times 10 to the 9. That's how we would express the age of the Earth in years in scientific notation. Alright, so let's go ahead and move on to the next example. which is average hair follicles on a human head. So there's 100,000 hair follicles. I found that pretty interesting. It doesn't really seem like the human head could fit 100,000, but it's nice to know. All right. So let's see. How do we express this in scientific notation? Well, we first have to ask ourselves, what is significant here? And we need to realize that since these 5 zeros are after the 1, which is a non-zero digit, they are going to be significant. Alright, so in total, our number here has 6 significant figures, therefore our scientific notation should also have 6 significant figures. Alright, so we're moving the decimal over to the left again, it seems. So 1, 2, 3, 4, 5 places over to the left to get it where it needs to be, next to the right of the first non-zero digit. Alright, so once you express this into scientific notation, first let us establish that this is 10 to the 0. Remember, anything to raise to 0 is 1. So since we're moving 5 places over to the left, our exponent should get bigger, right? Because left is bigger, like you see over here. So we should be going plus 5, right? To get a number of 1.12345 times 10 to the 5, right? And that is how many hair follicles there are on a human head in scientific notation. Notice that I have all 6 significant figures, and my exponent got bigger, not smaller. Okay? Let's go and move on to the next example, which is estimated total number of ants on Earth. And that's according to BBC. They say that there's 100 trillion ants on planet Earth, which is a lot of ants. Alright? So let's go and establish a decimal point right here. And let's count how many significant figures there are. So these 3 zeros, these 3 zeros, these 3 zeros, and these 3 zeros, as well as these 2 zeros over here, sorry about that, as well as these 2 zeros over here, are all going to be significant because they're to the right of the first non-zero digit, right? So in total we have 3, 6, 9, 12, 15 significant figures. Alright? So our answers are significant, our scientific notation should also have 15 significant figures. Alright? So let's go and see how many places we need to move over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places to the left. Alright? And remember, left is bigger, right is smaller. So our exponent should be getting bigger right here, right? So we have times 10 to the 0 plus, how many spots was that again? 14, right? Sorry about that. So that we end up with 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 10 to the 14. Right? So 3, 6, 9, 12, 15. So yeah, we have all 15 significant figures, and our exponent got much bigger. Okay? So this last one here, I think it's pretty cool. And we saw with the scene in Back to the Future where Doc Brown is all going crazy because he hears himself in a video saying that he needs 1.21 gigawatts for the flex capacitor, in which he decides to use the lightning from to use the energy from a lightning that strikes down on that tower. So let's go and express this 1.21 gigawatts into actual watts, which is something you might be doing maybe in your physics class or something. Okay? So we're going to use a little bit of dimensional analysis here. So 1.21 gigawatts, and we're going to be expressing this in watts. So remember, we're trying to cancel out gigawatts to end up with watts, right? So ask yourself, do we want to put gigawatts on the top or on the bottom? And if you answered on the bottom, you are correct, because anything divided by itself is equal to 1, which would cancel out gigawatts for us. So let's see. 1 gigawatt, and let's ask ourselves, how many watts are there in a gigawatt? Well, recall that on the unit conversion on the unit conversion table, a gigawatt is 1 times 10 to the 9, right? So there should be 1 times 10 to the 9 watts in a gigawatt, right? So all we have to do here is multiply this by 10 to the 9. So this is equal to 1.21 times 10 to the 9 watts, which is a lot of watts, right? So now let's practice converting this into a actual number. Let's take this out of scientific notation. Okay? So we know that since we went to the left, so we know that we're trying to get our exponent down to 10 to the 0, right? Which is what we had before. Everything that's 10 to the 0 is equal to 1, so it's basically multiplying by 1, which is itself, right? So since we're at 9 and we want to make our decimal smaller, or I mean our exponent smaller, we want to get this 9 all the way down to 0, right? So we know that we should be moving to the right in order to make that decimal place, or I mean that exponent, smaller. Okay? So let's go ahead and write this out. So 1.21, and we're trying to move this over to the right 9 spots in order to get to 10 to the 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So this number is, let's see, 3 zeros, another 3 zeros. Let's cross those off, an extra 0 with a 21 and a 1 right here. So what is that? 1,210,000,000 watts of power that Doc Brown needed for the flux capacitor. That's a lot of watts. Alright? So those are some silly examples to help you get a little gist of what scientific notation is. So let's go ahead and move on to the next set of problems, which is write each of the following numbers in scientific notation. And I'm going to zoom in a little bit here just so that we can have more space to work here. So let me go ahead and grab the blue. Write each of the following numbers in scientific notation. Recall that in every other example, we're always moving the decimal point to the right of the first non-zero digit. Alright? So for example, right here we have 1 point, 1 point, 1 point over here, 1 point over here, 1 point over here. Let's see, 4 points over here. Right? We're always moving over to the right of the first non-zero digit. If you notice here, the decimal is to the right of the second non-zero digit, which is not good. That's not what we want, right? So we're going to try to move it over here to the left 1 spot to get it next to the 4, right? And remember, right is bigger, left is smaller. Or I mean, left is bigger, right is smaller. Sorry about that. So we moved the decimal over 1 spot to the left in order to make 4.3, not 43 points. Okay? So we know that we should be adding plus 1 to our exponent, correct? So this should be 4.3 times 10 to the 4. And we still have the 2 significant figures that it gave us. Alright? So that is a completely right answer. So let's go ahead and move on to the next. This is a number that you're going to be seeing plenty throughout your time in general chemistry. However, you're not going to see it like this. This is known as Avogadro's number. Alright? But right here, we have the decimal point in the wrong place. So we know that we have to move it over here next to the 6. So we move it over once, twice, and 3 times to get it over next to the 6. To be 6.022. Since we move it over to the left, we know our exponent should be getting bigger as well. So plus 3. Remember, left is bigger, right is smaller. So this should be 6.022 times 10 to the 23. And the units for that number are atoms per mole. Or atoms or molecules per mole. Alright? Now that might not make much sense right now in this in your current stage of general chemistry, but you will be well acquainted with that number throughout the semester. Alright? So let's move on to the next. This is a lot of zeros, right? Now the question is, are they significant? Recall that only zeros to the right of the first non-zero digit are significant. These are not, right? So we don't need to worry about those zeros in our answer. We know that there's only 3 significant figures that we have to worry about here. So let's go ahead and express this in scientific notation. So let's move it to the right. 1 spot, 2 spots, 3 spots, 4 spots, 5 spots to get it to the right of the first non-zero digit. So 8.63, and this is all 10 to the 0, right? So 1, 2, 3, 4, 5 spots to the right. So we should be adding, or we should be subtracting 5, because remember, right is smaller, left is bigger. All right? let's break world records on Saturday. Okay, so 8.63 times 10 to the negative 5 is how we would express that number in scientific notation. Notice that we have 3 significant figures in our answer, just like the question gave us. Alright, let's move on to the next one. So we have a decimal point right there, right? So we're going to try to get it over here next to the 7. So we go over to the left once, twice, 3 times, 4 times, 5 times in order to get there, right? So we have 7.5, but do we express those zeros? That's something we need to think about. Alright, so recall that, like I said earlier, any 0 to the right of the first non-zero digit is significant. So all 4 of these zeros are significant to give us a total of 6 significant figures. So we must express those. So 1, 2, 3, 4 zeros to add on to our answer. And that's going to be so 10 to the 0. We moved over to the left 5 times. So remember, left is bigger, right? So our answer should be 5 places bigger than it was before. So times 10 to the 5. Alright? And that's our correct answer for that one. Let's move on to the next one. So right here we have 25 million. Alright? And the decimal point is right there. So how many spots do we have to move over? Well, let's count. 1, 2, 3, 4, 5, 6, 7 spots to the left. And just like we've done before, are these zeros significant? Yes, they are, because they're after the 5 to the right of the first non-zero digit. Or rather, the first non-zero digit here is 2, but it still makes the same point. Alright? So all 8 of these values are significant. Okay? So 1, 2, 3, 4, 5, 6 zeros in addition to our 2.5. Okay? And so since we moved over 3, 6, 7 times to the left, our answer should be times 10 to the 7, positive 7, because we moved over to the left. And recall, left is bigger, right is smaller. Let's move on to this last one right here. So 0.673 times 10 to the negative 2. Okay? So we're doing something similar to what we did in the first problem. We have the decimal point in the wrong spot, although they do have some sort of scientific notation going here. Right? So we have to move over once to the right in order to get it to the right of the first non-zero digit. Okay? So since we moved over to the right, our exponent should be getting smaller. So we're going to be subtracting 1 from here to give us an answer of 6.73 times 10 to the negative 3. And recall, we did express all 3 significant figures here, just like we have in our answer. Alright? So hopefully you guys found that helpful. Thanks for watching, and I hope you enjoyed.